Hello, welcome. In today's tutorial, we are going to be solving this beautiful problem. We call it Diophantine equation. So Diophantine equation. So now what are we going to do? M squared minus n squared plus 6m equals 0 for m and n belongs to positive what? Positive integers. We can say it like that. Set of positive integers. Or set of integers. Okay, so now from there, what are we going to do? M squared minus n squared plus 6m equals 0 for m and n belongs to set of positive integers. So now what you are going to do, m squared minus n squared plus 6m. Now I can add both sides. I can add 9 to the both sides of the equation. So I didn't change anything. Okay, so I'm just trying to beautify the equation more. Okay, so now from here I'm going to rearrange this or rewrite this. So I'm going to have m squared or plus 6m then plus 9. I will take this n squared to the back and I have what? I have 9 here. So now here, this one here can be written as minus 3 m plus 3 all square. That is perfect what? Perfect square. See, m plus 3 all square means that square this m, we have m squared, then plus square the next one, or let's say multiply 2 multiplying this and this, multiply together, we're going to have 3m, then square this, we're going to have 3 squared. So we're going to see our m squared plus 2 times 3 6m plus 3 squared, we have 9. So m squared plus 6m plus 9, which is what we have here. So which means this is same thing as this, and that is what I did. Are you getting it now? So I'm going to erase it. I'm going to erase this. Okay, so I'm going to erase it. Then I have what? n squared equals 9. So now from there, the next thing we're going to do, I want us to recall again that we have a squared minus b squared. This is different of 2 squared. This is going to be a minus b and a plus b. So we are going to use the same thing here. So m plus 3 is like my a and n is b here, right? So we're going to have this. Okay, it's going to be m plus 3 minus n, then m plus 3 plus n. That is everything here, which is equals 9. I believe you are getting what we are doing. So now from there, so we have this to be equals to this. Now obviously we can say that m plus 3 minus n is what? Is less than m plus 3 plus n, right? It's obvious because when you look at the negative here, so this one has contain positive all through and this one is minus, so which means that this will be smaller than this. Okay, so now let's pick 9. For 9, we know that this 9 can be expressed as 1 times 9, and also 9 can be 3 times 3, and also 9 can be 9 times 1. Okay, so we are going to pick the one that correlates with what we have here. So now here, 1 is smaller than 9, as this is smaller than this. So we're going to pick this one. Let's check the other one. This is 3, this is 3. They are the same. So these are not the same. So this will be cancelled out. Here we have 9. The first one, 9 greater than this. So the first one we are going to is less here, and the second one is smaller, while this is bigger. So here this is bigger, so therefore we're going to cancel out this one. So the only one we are going to use is this one. Are you following? So now we move on from there by having what? By having m plus 3 by comparison minus 9 minus n is going to be 1, the smaller one, and m plus 3 plus n is going to be 9. So this, we have equation 1 and we have equation 2. So now what we are going to do now is that we are going to do subtraction or addition, anyone we want. If we do subtraction here, If you put minus there, n minus n, that's 0, 3 minus 3, that's 0, minus n, minus plus minus n equals 1 minus n, we're going to have minus 8. So we're going to have here, this implies that minus n, that is minus 2n equals what? Minus 8. Then we divide both sides by 2. This will cancel this. N to be equals minus 8 divided by 2. I have minus there, minus, minus. Okay, we're going to have n to be 4. So we have n, one of the solution to be n equals 4. So I'm going to pick any of the equation that we have, n plus 3. Let me say from equation 1, we have m plus 3 minus n equals 1, right? So now from here, I'm going to have, since I have 4, I have n here to be 4 here, m plus 3, then minus n is 4, equals 1. Then we have m plus 3 minus 4, that will give me minus 1 equals 1. I will have to transpose this negative 1 to the right hand side. So we are going to have this 1, transposing this to the right hand side, it will change to positive. We have m to be 1 plus 1, that is 2. So you can see that we have m to be 2 and we have n to be 4. So therefore, the possible solution are m equals 2 and n equals 4. And as you can see, they are both belongs to set of positive what? Set of positive integers. And that is the end of the class. If you enjoyed the class, make sure you share this to your colleagues. Hit on the bell icon. Okay, if you have not subscribed before, then subscribe so that you'll be notified anytime you upload new content. Thank you so much for watching. Bye bye.